Okay guys, in this video I'm going to introduce you to horizontal asymptotes. One thing I didn't mention, but you should know about vertical asymptotes is you never cross a vertical asymptote. Your function can never equal to, or can never pass through the vertical asymptote because at that position it's undefined. That's a little contrasted with horizontal asymptotes because with horizontal asymptotes it is sometimes possible to cross them. Typically you don't really, I think more often you don't, but it is possible that you do. Okay, so what is horizontal asymptote? Well, first of all, notationally, we abbreviate it by HA sometimes. And this occurs when there's some number, k, such that f of x gets closer and closer to k as x goes out towards infinity. Or, similarly, f of x gets closer and closer to k as you go to negative infinity. And, I can't think of an instance with rational functions when those two are different. Yeah, nothing comes to mind really off the top of my head. That I think it's, as far as I can think, it's gonna always be the same as x goes to either positive or negative infinity. And actually, we're gonna see that in a second. Watch this. Okay, notationally, horizontal asymptotes are horizontal lines, so they have the equation of a horizontal line. Y equals a number, right? Y equals k is the equation for a horizontal line at k. Now there's two possibilities, two ways that you can get a horizontal asymptote. Either when the numerator it has a lower degree than the denominator, or if it's equal. Those are the two instances where you get a horizontal asymptote. The easier one is when the numerator degree is smaller than the denominator degree. In that case, your horizontal asymptote is always going to be simply y equal to 0. So right at that x-axis, that's where your horizontal asymptote is going to be. So here's an example. The degree on the top is 1, right, 3x. The degree on the bottom is 2. Since the bottom has a bigger degree, the horizontal asymptote is 0. Now, let me give you a quick justification for why this is. What's going to happen as x gets really, really large? As x gets really, really large, everything in that top polynomial is negligible compared to that first term. So essentially, 3x is the main thing that matters from the top. And similarly in the bottom, as x gets super large, this x squared term overpowers these other guys. Just think of x as being like a quintillion, trillion, billion, whatever. These guys are going to become negligible compared to the x squared term because that's going to grow much faster. And so it's going to end up looking like whatever 3x over 2x squared is. Now, if the top is a lower power than the bottom, that bottom number is going to overpower the top, and it's going to end up looking like 0. So it's going to get closer to y equal to 0. Now let's look about when the numerator and denominator have the same degree. Well, in that case, you just focus on the leading coefficients, a over b, and that's going to be your asymptote. So here's the example. 3x squared plus 5. So this looks kind of similar to the other one, but this time the first term is squared. 3x squared plus 5x minus 7, or 2x squared minus 3x plus 1. These terms don't matter as x gets really, really large, either negative or positive, because this is going to be the most powerful term, the x squared term, right? These guys don't really matter, so they're going to essentially disappear, leaving you with essentially 3x squared over 2x squared. Now, these guys, they're evenly matched, right? And so as x gets really, really large, like just think of 3 trillion over 2 trillion, because these are the same x squared terms. 3 trillion divided by 2 trillion is still 3 over 2, right? So you're going to get closer and closer to 3 over 2. What about if you put negative trillion into x? It's negative trillion squared is negative trillion squared. It's positive trillion squared, right? And then same thing for the denominator. It's going to be same sign. So you're going to still end up with 3 halves. Now, this would still work even if this was an odd power, even if those are negative powers, because negative divided by negative is still going to be positive. So at the end of the day, you just get the result of those coefficients divided by each other. All right, let's do the questions. Which one are we doing? 6 through 9. Okay, first of all, I wonder if we... let's just do it right here. Because these are easy ones. So horizontal asymptotes. Here, top number has a degree of 0. Bottom number, or bottom polynomial has a degree of 2. The bottom is bigger degree. So you have a horizontal asymptote at y equal to 0. Super easy. Okay, second question, number 7. Same degree, right? Remember what we just said? These guys become negligible compared to that first leading coefficient or first leading term. So I don't care even if that's 100,000. Only thing I care about is this two leading terms. And the leading terms, leading coefficients are 4 and -2. So the horizontal asymptote is simply 4 over -2. But of course that reduces. So that's y equals to -2. That would be the horizontal asymptote. Okay, easy. Okay, moving on right on to number 8 and 9. So now it says complete the two problems. As x goes to -infinity, what is f of x? And positive infinity, what is f of x? Well, if there's a horizontal asymptote, it's just gonna approach that asymptote. It's gonna approach that. That's what it is. Did I talk about the notation? I think I just I feel like I might have forgotten the notation. Oh no, I didn't. Okay, it's okay. We're gonna see it right now. So as x goes towards -infinity or positive infinity, f of x approaches the horizontal asymptote if there is one. So in this case, and if there isn't one, then it's just gonna typically go towards positive or negative infinity, right? In this case, okay, again, I don't care about these other terms. I only care about the leading term. I've got x compared to x cubed. So that means my horizontal asymptote is y equals to 0. So now, as x goes to -infinity, f of x approaches 0. And as x approaches positive infinity, f of x also approaches the same 0. So that's easy as that. Okay, what about this guy? Again, everything, it doesn't matter except for the leading coefficients. Those are the only things I care about. I got the same horizontal. I'm actually reading the same question as before, yeah? I'm reusing the same rational function. Again, horizontal asymptote, so y equal to -2 in this case, right? And so, what happens? As x goes to -infinity, well, f of x is just going to approach that asymptote, -2. As x goes to positive infinity, well, f of x goes to +2. -2, I mean. Sorry, -2 again. -2. Yeah. To kind of just convince yourself numerically, then just look at what happens if you plug in a really large value for x. Just think about it. Let's say x is 1,000. It's going to be 4 times 1,000 squared over -2 times 1,000 squared, which is 4 times 1, 2, 3, 4, 5, 6 zeros. So it'll be 4 million, and this will be -2 million, and that's going to be -2. And you can actually throw these guys back in. You can actually throw these guys back in and just pick a bigger value for x, and what you see is this is going to be a number that's still getting closer and closer to -2 as long as you pick a large enough value for x. Okay, that's it, guys. So that's horizontal asymptotes.